Hi, everyone. Welcome to Project Pro's podcast, where we speak with industry leaders on business outcomes and use cases of AI and particularly Gen AI. Today, we're going to specifically talk about how to tailor the right LLM or a multimodal model to a specific Gen AI use case. And to help us understand this, we have Dr. Saigeetha Jegannathan, who's probably the best suited to help us understand this. Dr. Saigeetha is the chief data scientist at IBM, where she focuses on, among other things, specifically LLMs with use cases such as code generation, application modernization, and multiple other Gen AI use cases. And as part of that, she also collaborates with the Watson X team. Dr. Saigeetha has a PhD in physics. She has almost 15 years of experience across data science, ML, deep learning, and more recently, LLMs. Dr. Saigeetha, thank you so much for taking time to do this. It's wonderful to have you on the show.
Thank you, Binny. So it's a pleasure to be here. So hope whatever I'll be presenting on, particularly the model selection, would be helpful to the viewers here. Okay. First of all, thanks Project Pro for giving me this opportunity to speak about LLMs and how do we choose the right LLMs for our use cases. So I'm looking forward to share some of my observations, experience, and insights with the viewers here. So today I'll be focusing on primarily certain aspects of LLMs, right? Because as we know, generative AI is the most upcoming field and with a lot of interest. And we see industries is trying to transition from the traditional AI ML to the generative AI to resolve some of their long, existing problems, very complex problems, be it in clinical trials or software development and so on and so forth. So, but how do we choose the model for which is the right model that for our use case? So how do we choose that? So I would be focusing on that and probably like share some of my experience, insights, and observations with you so that that would help you in choosing the right LLM for your use cases. So we'll start with the AI and its evolution and how we are transitioning. We are at a kind of a very, very important period where we are transitioning from the traditional AI ML into generative AI. And we would also talk a bit about what is generative AI, how this is different from the way that we used to train these models before, and what are the advantages that we bring in, as well as some of the limitations as well. And then we'll talk about what are the types of LLMs or models here, and how do we choose the right model. And I would also give some insights on comparison of large and smaller foundation models, because where do we use large models, where do we use smaller models, and how the advantages and limitations. And then we will also talk about challenges and limitations in using the LLMs. So these are some of the topics that I've chosen, and I hope these would be interesting and useful for you. As we have known, AI, artificial intelligence, is all started. It all started several decades back when Alan Turing tried to see if machines can replicate or mimic the human capability through an experimentation, which he called Turing's test. I think we all know about it. So it all started with that, and there is this entire data science have evolved over a period of time, or I would say AI has evolved over a period of time, right? Starting from the analytics, statistical analysis of the data, or expert systems where we use the rule-based engines to determine or predict the from the existing data, the outcomes. So those was the first. And then this must be like 20 years, so on, like we've been talking about. Then came the machine learning. Then what we did was we tried to find out if machine can learn just like a human does, right? So a child is supposed to learn almost 30,000 objects within 5 years. So that's the capability of the human brain. Can machine learn similarly? So that was then the machine learning came into picture. So we have supervised and supervised learning methodologies to train these the machines to learn certain repeatable tasks, so that that can be avoided, or that can be set aside by the humans to take up more complex activities. So that's how the machine learning came into picture. Then we moved on to the deep learning. Deep learning is an enhanced version of the machine learning, wherein we tried to mimic not just the functionality of the human intelligence, but also the structure of the human brain. So basically, the with all the perceptrons, neural networks, and all those architecture in place, we try to mimic the structure of the human brain along with its capability. Now we are moving into a different dimension itself, where we are going to use the foundation models. And that's how, of course, people think like in 2020 when ChatGPT came into picture, people were excited, and that's the start of these large models. Not so, because even before foundation models were existing, just that there was no we were not using a fancy term like generative AI and so on and so forth. So I remember 4 years back, during the COVID period, we were using certain foundation models for to analyze the clinical trial data. So it has been in use for quite some time, but over after ChatGPT came into picture, there's been an enhanced interest by not only data scientists, but also the common men. So that's how we are seeing the evolution. And before I go into generative, what do we mean by generative AI? As we said, foundation models, they are based on certain architecture called transformers. So it again started in 2017 with Google releasing a paper on it. And that's how as I said, even before the ChatGPT, these foundation models have been in place. So what do we mean by generative AI? So we've been using generative AI foundation models, LLMs, more or less, they all merge to a single point. Generative AI, basically, it's a category of artificial intelligence system that has the ability to infer, generate data, be it text, images, or audio, through complex algorithms. So I would also talk about what is the difference between the foundation models and the AIML, the traditional methods that we have been doing it for quite some time. That is what is defined here, right? So I remember like 4 years back when I was working with an insurance client, wherein we implemented AI tool that would actually automate the entire claim. It's basically a claim assistance system to automate the claim settlement for the damaged cars in the during accidents. So wherein what we used to do was, for every step, new separate models we used to create. So we would have one model to identify the car make, we used to have another model to identify the damaged parts of the car, another model to determine the color, another model to determine the quantification, or to quantify the damage, whether it is replaceable or repairable kind of. So I think we used to have, for every task, we used to have separate models. And the system used to be very heavy. We used to run it on large GPU systems. Of course, that was the need of the hour at that time. But we used to have multiple number of models doing different tasks. Then we like now we have the foundation models, where a single model can it do multiple tasking, just like we do, right? Where we cook, we read, we do multiple things. So I think, can we have found similar models that can do multiple multitasking? So that's where the foundation models came into picture. And as you know, ChatGPT is one of the most known LLM that can do a summarization, that can do a search, semantic search. It can go and search certain information and provide you. It can translate. It can do a lot of things. So basically, these foundation models are meant for multitasking, and they are big. At the same time, they do the foundational jobs together. So that's the reason why they are called foundation models as well. Now, just to extend the usability, right? How this is like, as I said, we are in a transition period where multiple enterprises, the businesses are keenly looking into adopting the foundation models primarily to resolve some of the very complex problems they had. And using AI ML, we were able to resolve certain aspects of it, but it has like opened doors for many, like, particularly, as I said, there are areas where, yeah, traditional AI ML couldn't efficiently do, such as clinical trials or software, automating software development, which I am currently involved in. So those kind of areas where you can generate the code, you can transform the code, optimize the code, generate documentation for the code, so on and so forth. There are so much fields that have been opened up with the advent of foundation models. Now we have the multimodal area, approach, where we have massive external data, including images, text, audio, structured, unstructured, so many other different types of data, all being these massive models can process and provide insights. It can be querying, it can be semantic search, it can be translation, so, and generation, text generation, etc. So that's how we see that the enterprises, the individuals, enterprises, able to see the power of these models and trying to adopt it in their in their systems. Now, in the slide, I had just, this is not a very recent one. We have a lot more models that have been added off late, with GPT 4.0 coming into picture, Llama 3 from Meta that have been updated recently, Mistral trying to take over. So I think this is a bit of an older slide. But what I'm trying to say is there is a lot of models that are available, both open source as well as licensed. Now the question come into picture, right? How do we identify which is the right model I need to use? Because every night the way that I do, like, every night you have you need to check, you need to get updated on what is happening, because things are changing so drastically. So, so many new models are coming up with a lot more parameters and so on and so forth. So we have to keep on getting updated. But there's so many options in front of us. How do I choose the right model? That's a question that comes to our mind. Before we move on to choosing the right model, what are the key criteria that we need to take into consideration on what and all we need to look for while choosing the models? We need to understand the types of models also. This is a very basic, like, I think there are lots of sources available, online sources people can go through, but there are three major types of LLMs. Of course, there are a lot more things are coming up. But basically, there are three types. One is the encoder, the decoder, and encoder-decoder. The most known and kind of a workhorse is the decoder model, and GPT, Llama models are part of that. Encoder is specifically for sentence classification, NER, named entity recognition, Q&A, semantic search, question and answering. So these are some of the use cases where you can use the encoder type of models, be it BERT, right? You have BERT is the most common one, which is open source, and people can use it to classify all those, like, the encoder models would be very much helpful. While coming to the decoder is mainly meant for text generation, wherein I give a word, can I predict the next word to that? So that's where the encoder model comes into picture, pure encoder model. And many of the current large models or widely used models are decoder based. Now we also have a smaller category, which is encoder decoder, where it is mainly used for summarization, language translation, and so on and so forth, be it BART, FLAN T5, T5, UL2, and all those. So I think this is very important. We need to, if we have to align our use case, suppose I'm having a use case where I need to generate text, where I need to generate code, where I need to generate something, then I go for a decoder type of model. If I have to do a search, suppose I have, I am developing a chatbot. Okay, for I would give an example for a health insurance client. I'm developing a chatbot wherein the user is asking a question: what is it included for me for this particular medical condition? Then the tool or the backend system has to go and search from a large number of documents, benefit documents, basically talks about the medical conditions, what is included, inclusions, exclusions. So there's a huge knowledge base available. Basically, the system has to go and search for the query, and that's where the encoder type of models may be very much helpful, where it generally goes and do a semantic search and pulls out the information. And of course, for summarization, if I have an article I need to summarize, or recently I was checking on a use case where these financial reports, the client wants to have a summary of the financial reports, because they may not have, the leadership may not have much time to go through all the reports. So can I summarize and provide only the relevant information? So there you can go for an encoder decoder type of model. So I think based on the use case, we may have to choose the models, the type of models that are available. And as I said, we have a huge number of open source in the Hugging Face. You would find a lot of models. Llama models are available, and of course GPT-4 3.5 and the latest GPT 4.0. So I think there are lots of options available, but we have to choose carefully based on the use case or based on the requirement that we have. Now, I would like to put some, talk about certain criteria that we have seen, like based on the technical aspect, how do we identify the right model for our use case? But what are the other things that we need to keep in mind while selecting the model? Right, and that it's not just about technique, but also the other things, right? Be it usability, be it fine-tuning capability, be it the ethical standpoint, so many others, governance. So I think we have to take into consideration these points as well. Is very, very important. One, as we have seen, the use case suitability. We have just seen whether our use case is a generation use case, is it a question and answer, or is it a summarization? What kind of use case that we are working on? So based on the problem statement, you choose the model. The other part is model size. There are large models, there are smaller models, moderate model, based on the size you can categorize. You have, and we have seen I would also give some observations. We have seen for certain code related use case, we have seen Mixtral equally working to Llama models, which are 70B kind of models, which are equally good. So Mixtral is a smaller model with 8B kind of, so but it is equally. So I think the size of the model also plays a role, because you may have to put this model or call this model somewhere. And if you have a restriction on the infrastructure, go for a smaller model. So I think based on your domain specific task, as well as on the availability of the infrastructure, which I have put in as a separate point, the availability of the infrastructure, you can choose the right model. Then fine-tuning capability. This is one area where I would like to put in or give more points or observations here. We've done a lot of work in fine-tuning. So there are 3 ways you can enhance the performance of a model. Generally, we call it as 3 areas where you can intervene and enhance the performance. One, prompting. We all know how we can prompt, give the instruction to the model, you ask for it, and the model provides certain outcome. The second one is the fine-tuning. The fine-tuning is basically what happens is these are big models, several millions, billions of parameters being used for training. If I'm having a domain-specific data, which the, say, suppose out of box, the model is giving, say, 30% accuracy, but I have to make it 60, 70% accuracy. I can go with fine tuning. Even after prompting, if I need to enhance it further, there is an option to fine tune. It's different from training, complete training of the model, because that is a very different, difficult task because of the large infrastructure required, the data required, and a lot of other, dependencies. What we can do is, using parameter fine tuning, you can add the domain specific knowledge to the model without disturbing the base weights or base understanding learning of the model itself. So that way you are enhancing the model with additional data or insights without disturbing its older learning. So that is the fine tuning capability. There are some disadvantages, and there are certain things that we need to take care of, but I'll come to that later. But this is also one area where people are looking at. Recently, I was speaking with a banking client. The client is keen because of the privacy, the data privacy, the client, the data privacy that is in place within their organization. They want to fine tune a model with their own data that is not available, to the external, their competitors or any other external person who are using. So they want their own customized model. So that's where this fine tuning comes into play. And you need to look, if your use case and if your organization requires a customized model, then you can go for fine tuning. And you can also decide your model based on the fine tuning capability. Say, for example, certain models you cannot fine tune, that option is not available, but certain models you can fine tune. And also we have seen smaller models, or I would say the enhancement you can see quite easily in a smaller model. It's easy to fine tune the smaller model than the larger one. And the response of the smaller models to fine tuning is much, much better than larger models. So that's where we are all moving. Actually, if you ask me, the trend would be going forward. The smaller models may play a very, very major role, particularly for certain domain specific tasks. If you want to fine tune the model, smaller models are easy to fine tune. So you would find that kind of a trend going forward as well. So that is one very important thing that you need to decide. And another, factor that you need to look into the cost. Of course, you want to go for an open source model that you can download in your from your own system, and if you have GPUs, and use that. Or if you are going for a licensed model like GPT-4 or any other, so that, again, like how much of support and maintenance capabilities available. All those things are scalability. Again, one more area where we look for is scalability. So I think this is also one of the major factor where you need to consider while choosing the right model. The last part is the governance. There's a lot of work that is going on from organizations like IBM, putting in a lot of emphasis on the governance, ethics, and governance of generative AI models. We've seen, because it's like I keep giving this example, right? There, say, suppose previously I'm a teacher, and there is a child being sent to me for learning, and I'm here comparing the traditional AI ML models with the Gen AI models. That child has no prior knowledge, so I teach the child. The child learns. So there, it's easy to mentor, mold the child, and that's how we were doing it with the AI ML, where you need to train the system, train the model with all the data that is required for it. Otherwise, the model would not work. Whereas generative AI is the other way, where I am, as a teacher, I get a student who is learned, who has some prior learning. So he comes with a prior learning. So I have to, it's a little difficult to mentor or mold that child for doing certain activities. So I think there the governance and ethical considerations play a very major role, because these models come with prior learning. There can be hallucinations, there can be some unwanted responses being thrown, so there can be bias, drift, so many different areas where you would find these models behave. So I think the the ethical and governance is a very, very key aspect when it comes to generative AI. So, what are the potential risks and data protection? This is again one more major question that keep coming, right? Is my data protected? So, I think that's where like we have categorized. Of course, I've not added this as part of this presentation, but we have categorized as four major categories options. One is fully public, your chat GPT kind of, where everything is public, your data is also public. So whereas the other extreme end is private models, where the big banks like JP Morgan Chase or big banks have their own model trained on their own data. Of course, the maintenance, the cost of maintenance, training, everything is high, but the data protection is very high, very high out there. Whereas there are two hybrid models wherein Azure, AWS, IBM, Watson, like that, wherein the model you procure the model and use in the cloud. The other one is you download. The third option is you download the models, just like how you can do it. Llama models can be downloaded or BERT, and then you can fine tune it or you use it in your own premise, right? So those are different options, and for each of them the data protection, the privacy of your data varies. So I think those are some of the key aspects we have to keep into consideration while choosing the right model for all our enterprise use cases. Okay, moving on. I'll first finish off the comparison of large and smaller foundation models, and then we can move on to the challenges and limitations, and then we can open it for question and answer. Now, we have done a lot of study on the large and smaller foundation models. That's what I was talking about. Like you have options, you have several options, several models that are available. As I said, we have seen a couple of lot of insights in the previous slides on how do we choose the model based on the type of LLMs, based on all the factors that we spoke about. In that, one aspect or one factor that I mentioned was model size, because it is a major area where, because it is directly related to the cost, right? Maintenance, your infrastructure, everything comes into picture. Now, we have done a lot of study and we benchmarked as well. Some of the key, I had tried to consolidate the advantages and disadvantages of the large and small foundation models at a very high level. Of course, we've done a lot of experimentation. Any questions come up, I can answer. One is with large foundation models, the key advantages are it's very high capacity. It's kind of a multi-tasking, option that we have. Say, for example, GPT-4 or Llama 3, whatever we are talking, they can do multiple tasks. They can do summarizations. They can do question and answer. They can do this translation. They can do generation. So multiple. So one model can do multitasking. Better performance. These models have been, a lot of I would say implementations and a lot of governance put into place, so it would have a better performance, versatility, where, as I said, it can do multitasking. Basically, these large language models have rich representations. That means different type of data would have gone in training this model. See, I was testing with GPT-4, and I was like quite surprised to see the GPT-4 has been very well trained on SAP data. SAP data, many models failed, but GPT-4 is performing pretty good on SAP data. That is, you see the better representation over there. A lot of research advancement. So people have invested, companies have invested in generating this large model. So you would find better performance over there. And then quicker and effective out-of-box demonstration. See, it's if you want to do a quicker demonstration, try out something very quickly, experiment. Then these large models, you don't need to intervene so much. All you need to do is to prompt it correctly, and it would give you the right answer. So do a very quick and dirty kind of small experimentation. Quickly show to your client or to anyone For a demonstration purpose, I think large language models is very much useful. But when it comes to the disadvantages, there are few. One, what happens is computational, it needs computational resources. These are big models, be it like, 14 trillion we are talking about, or, 70 billion kind of very large models. It requires the large computational resources. To maintain this model and over a period of time to keep on enhancing it is a major task, because these are not small models. You need larger amount of data to even fine tune and to enhance it. Of course, the environmental impact, we talk about carbon emission and so on, so many other factor here. So if I have to do a very smaller task, do I need this big models to do it? Can I do it with a smaller model? That's a question that come up. So I think that is also one more major area that people are looking into it. People are doing a lot of experimentation on that. Data density and fine-tuning complexity. One area that, as I said, I touched upon this, we've seen, we did an experiment. We took two models, a smaller model like star coder, like it's a part of a Hugging Face. It's a 15 billion model. And we used Code Llama, which is a 34B or a 70B, Llama to 70B chat. What we did was we fine-tuned on several use cases. One of the use case was on the banking Swagger files, basically converting the banking Swagger files to a Python Flask code. Out of box, the Llama model was pretty good. It was like out of 5, the benchmarking number was almost 3.5 or 3.7 kind of. Whereas the star coder, which is a smaller one, it's an open source model, what it out of box, it gave a benchmarking accuracy of almost like 2 maximum to 1.8 or 2. Then what we did a parameter fine tuning of these two models, bigger model and smaller, and with say 500 odd data. And what we saw was the star coder, after fine tuned, was able to pick up the new learning very quickly, very, very well. And the performance jumped from almost 1.8 or 1.7 to almost equivalent to the Llama model. It was like almost 3.3, 3.4, whereas Llama model was 3.4 or 3.5. Whereas when we tried to fine tune the Llama model, what we found was it was not able to enhance its capability through that. So even with a smaller amount of data, the fine tuning of smaller models is pretty. Of course, what I'm saying is, it may again, like it's an experimentation we have done. Certain areas possibly it may not be so. It also depends on the data. But this is where one very interesting observation we had, and not for just one use case, for several use cases we have seen. The smaller models able to pick up or learn the new data pretty easily or pretty efficiently than the larger models due to its size as well. So the fine-tuning complexity of large language models are pretty is one of the limitation. And then interpretability and cost as well. Cost is one major area where people would look into in choosing the model. When it comes to smaller foundation models, right, there are there are pros and cons in both. So while choosing the right model, we have to keep into consideration all these factors and then choose the right one. When it comes to smaller foundation models, it's low computational cost. The cost itself would be less. Faster inference, because these models are very small in size, they would be faster while inferencing. Easy to interpret, because it may do n number of tasks, less number of tasks compared to the larger models, because it's easy to interpret and easy to fine tune. I just gave an example. It's easy to fine tune. And domain adaptability. That's why what I'm foreseeing the coming years. Now things have to settle. Like, people are pretty much excited, trying out, doing a lot of experimentation with LLMs. But when it settles, when the enterprises will adopt these models to their use cases, domain adoptability is going to be a very, very big task. And how are we going to adopt these models to our domain? That is one area where the that time I feel, that's my opinion, that smaller foundation models will play a major role for certain, at least for certain not so common task, right? Leave about like common task where you are summarizing or question and semantic search or translation kind of, but there can be certain very, very specific domain related tasks that you need to fine tune even a large model. In those cases, I think the smaller models are easier to fine tune and adopt. So domain adaptability is going to be a major area where people would look in, and smaller models have a major, it would play a major role. And easier maintenance, of course. And then, but there are, of course, limitations to smaller models. One is out of box capability may be less, because if you want to do a quick experimentation, show certain outcome, that time the performance may not be that good. And of course, like transfer learning capability and so many other. I think this is at a high level. This is how we view the compare the large and smaller foundation model. So as you choose the right model, all these factors should be taken into consideration, and that would help in choosing the right model for your task. So I've just move on to the last slide, wherein I talk about certain challenges and limitations. Of course, this is a very major area where people are looking into govern, and particularly in the generative AI governance. So there are, I think many of this would be known to you, but since this is a very important area, that I just wanted to touch upon certain aspects to it. Some of the challenges and limitations of these large language models would be this, right? As we talked about, there can be data bias and fairness, because it comes with certain pre-learning. It comes with pre-learning, so it has been trained on certain amount of data, so there would be certain amount of data bias and fairness. Other one is ethical concerns. Sometimes these models behave in a different way, beyond what we would expect. So I think that is also, there should be a very, very good governance in place to manage, or to check these models, to monitor these models. Interpretability and explainability. So this is one area where, as a data scientist, there's a major difference between what we used to do before. For us, these models are black boxes, right? They've been trained on certain amount, large amount of data. We do not know, many times we do not know on which data this has been trained on. So is it being trained on private data, PI, and so many other. That's where the countries are putting in place very stringent rules and regulations in using the generative AI model. So I think we have to be considerate about that. The other one is explainability. This is another area where we need to focus on. As a user, if I am using a generative AI model to say, do a search and provide me the relevant outcome, I need to know whether the outcome, it has picked up from certain reliable source, or is it something reliable or not. So that is where the interpretability and explainability is a very important task. So what we have done in many of our Gen AI work that we have been doing, we are adding this explainability as a very major feature. For example, there are many ways you can do it. One, if it is if it is a chatbot and it's pulling out certain information from, say, X number of documents, these are the documents it is pulling out, it should be able to provide the source of that information. Okay, this is the outcome for your question. This is my response. I have picked up this response from these documents, say n number of things. So I think that kind of explainability, transparency is important so that I can go back and validate if the outcome is correct or not. So I think this kind of checks and balances features, the explainability features should be in place. So when you develop your GenAI models, please make sure such features are available as well. Then resource availability, I know, like, or most many times these LLMs are very large and you require GPUs. Even to fine tune these models, you require GPUs to do that. And domain adaptability we spoke about. This is one major area where a lot of work will happen, and it's already started. This is something that we need to see how this is going to progress. Again, data privacy and security. So as I said, there are four major options we have, from fully public to fully private, and we need to consider, based on our use case, we need to consider where do we stand and how do we use. So I think these are some of the challenges and limitations in using LLMs. This is also we need to consider while choosing the right.
Thank you so much. That was extremely knowledgeable input for all of us. Basically, very focused on SLMs, small models, and also the fine tuning aspect of it. Very helpful. Had a couple of questions if I could go into it. So one is, it's a pretty basic question, which is, you started off that slide where you said traditional AI models, we had very specific task oriented training and they would do only those specific tasks. And now we are in a world of LLMs where they are trained on a large corpus of data so they can do lots of tasks. Now, when you look at SLMs, we are going back to doing very specific tasks with specific things. So how are these SLMs different from the task-oriented earlier AI models?
Right. See, basically, I would see this way. SLMs are nothing but foundation models, but on a smaller scale. That's how I see it. Okay. They are also capable of doing multitasking. Say, for example, I would take the code, star coder, or Mixtral. Mixtral is a smaller model. It can do documentation. It can do search, semantic search. It can do any number of things. But the parameters, the number of parameters it has been used to train. Of course, Mixtral come with a new technology. They have they split the entire thing into smaller chunks and they train. There is a way that they do. But I would say I would not compare the smaller foundation models to the old traditional AI/ML. Instead, I would see it as a smaller version of the large foundation model itself. Of course, there can be certain areas where it wouldn't have been trained well. Possibly, I take an example, SAP data, but many models are trained well. Certain models are trained very well, like GPT-4 is one of the top performing model. So, but these models may have some kind of an understanding. Mixtral may have, say, 20% of understanding, whereas GPT-4 may have, say, 40-50% of understanding. So it's a scale. The scale is what we are talking about. They are still foundation models. They can do multitasking, but on a smaller scale. It depends on how much data they have been used or parameters they have been used to train. That's how I see it.
Understood. Got it. And when you say the SLMs are kind of smaller versions of the LLMs, just to understand that slightly better, is it an entire class of language models that are separate from LLMs that are SLMs, or are SLMs largely kind of an instantiation of one of these LLMs but fine-tuned on smaller data sets?
Right. Okay. So I would, the way that I view it, possibly people may have a different view. The way that I categorize them is based on the number of parameters it has been trained. Say 8 billion, for example, Mixtral, or star coder is 15 billion. Whereas I have Llama models, which are 70 billion, GPT trillion. So based on the number of parameters and is what I look at. And I would say from out of box. So there are two levels we can talk about. One, out of box capability, and then fine tuned capability. Okay. Out of box, say, suppose I am working on a use case. I'm trying to say generate a, since I work on the SDLC, I'm taking that example, but say I'm trying to generate a say Java code using star coder and a Llama model. Now, the out-of-box accuracy may be just 20%, I may get it in star coder. possibly. I'm
Mm.
just, this is like kind of imaginary numbers, but I'm
Yeah.
just giving.
Yeah.
Whereas the Llama model may be out of box, may give me 40% accuracy, 40,
Mm.
50.
Mm.
Now, what we had done was we tried to fine tune. That's the next level.
Mhm.
I have taken 500 data points.
Mhm.
I tried to fine tune these two models with the
Mhm.
same data, try to
Mhm.
compare.
Mm.
Okay. So when I trained the star coder model with the 500 data points, the accuracy enhanced by certain amount.
Okay.
Whereas the large model with the same data, since it has been trained on a very large parameters, maybe 500 data points, maybe a very less, it's kind of a drop in the ocean possibly,
Yeah.
that the retraining capable or the fine-tuning capable, the enhancement was pretty limited, was
Mm.
very negligible, we could see. So that's where
Okay.
I could come. Here, the jump was quite significant, whereas there was no hardly any jump over there, possibly by again, like it depends on the data. There is a dependency on the data, but this is
Yeah.
one very interesting observation we had with the when we were working on the code use cases.
Okay, okay, that's very helpful. And since you were mentioning out-of-the-box capabilities and accuracy, one thing I was curious about is in the traditional data science way of modeling, there are pretty established accuracy scores and metrics that we quantitatively look at.
Right.
In the world of LLMs, how is that being done? Is there an expert looking at it and a gut check, or is it some kind of difference in the vector space between an ideal solution and what comes? Like, how do you look at accuracy in the LLM space?
Right. So this is a evolving area.
Hmm.
Basically, there are certain, you have certain data set. There are methodology or data set
Mm.
for, benchmarking purpose. I think that
Okay.
is available as part of Hugging Face as well. People do
Yeah.
it at a higher level, but
I see.
that that may not be, sufficient for us when we are looking at a use case. We have seen that
Hmm.
there is a kind of a difference over there.
Mm.
What we do as part of our team, we do two types of benchmarking. One is the
Mm.
performance benchmarking and the efficacy benchmarking. But primarily in performance benchmarking, we look at the errors, how many lines of the generated text or code is good,
Yeah.
correct? Is there any system errors that are coming in? So those kind of performance related, is there any kind of, I would say, any optimization issues, so any unwanted lines of text or code coming in. So those are the performance that we look at. Whereas the
Mm.
efficacy part is more towards the logical part of it, whether is that generated text is in line with what we are expecting. When it comes to code, how many lines of code is actually logically correct. So
Yeah.
those kind of logical efficacy part, so we benchmark on both.
Okay.
Okay,
Okay.
so, and this one is very use case specific, as I said, but at a high level, we can call it both performance and efficacy benchmarking because both are important. We need to know even the time taken, how long it takes to generate the outcome. That is also
Mm.
one kind of performance benchmarking we need to add. So I think there are at least 10 to 20 parameters we look for both these benchmarking. So I think there is a common methodology people use. There are some standard set of data that are available in different, even a Hugging Face you can download. So I think that is one common thing at high level. But when it comes to use cases, you need to benchmark both on performance and efficacy. And
Yeah.
there are certain parameters that should be very specific to your use case. And
Okay.
as I see, it's still evolving, right? As we
Mm.
used to do when the AI ML, we used to do this precision recall and all those. Now it's pretty different now. That's why the even the benchmarking, the accuracy, it's a kind of a new thing for us because here it's a totally different, and
Yeah.
we are now trying to put in together a structure of how the accuracy metric should look like and how we can benchmark. So that's how it
Yeah.
is.
It's a pretty amazing world we live in, right? I mean, we're figuring it out as we go. So,
Right.
yeah. So, the other thing you mentioned was obviously SLMs work very well in narrow domains, right? While a lot of people listening to this, they're trying to figure out what model to pick for what, and you had a very nice slide about encoders, decoders, encoder, decoders. So, is there a cutoff line after which SLMs become more relevant, and where is that cutoff line? For example, if you take healthcare, is it anything healthcare related in SLM healthcare, or maybe inside healthcare, let's say insurance claim processing, is that an SLM? Or maybe inside claim processing, there's a specific workflow, is that another SLM? Like, how would you think about different
Okay.
degrees of SLM?
I would not categorize LLM large and smaller SLMs with respect to domains because
Mm,
with every domain, both LLMs and SLMs would play a role. Again,
mm,
it depends on the use case. For
mm,
example, be it I am talking about, say, I'm doing a clinical trial, medical. I will take a
yeah.
medical use case scenario.
Mhm,
Now I have to do a generation, right? I need to generate, say, a patient label. For example, I
mhm,
need to read the constituents of the drug. I need to generate a patient label.
mhm,
Then I have to go for a generation capability, which is the decoder type of
mhm,
models, GPT,
mhm.
llama models, where it can
Yeah.
generate that.
Mm,
And even like, I'll come to the SLMs as well,
yeah.
to that. And first of all, I'll talk about the decoder part of it. I'll just give an example and then come to this.
Please. Please.
Now, in the same clinical area, healthcare,
Mm,
I may have another use case where I am trying to classify the symptoms of a disease or symptoms of a patient, whether it
yeah.
is due to the disease or is it due to the drug or is it due to some accidents or whatever, right? The symptoms can be anything. So there it's more of a classification problem.
Mm,
So I go for an encoding methodology. Can I use BERT? And in fact, for one of the work that we have done for a pharmaceutical industry, we used BERT
mm,
for classification of symptoms. That's why I am able to give that example. So I
mm,
think it, first of all, the decoder encoder decoder and combination of encoder decoder, kind of like, based on what do we want to achieve. Is it a
mm,
classification problem? Is it a summarization? Is it a generation problem? We need to first identify that. That's the first step. And the second step is where I would go for whether I need a large model or a smaller model. Say, for example, I'm doing a summarization or I'm doing certain very generic task like summarization or text generation or classification. Then I can go for a large model which has been already trained on so much data there, and it can do the classification efficiently. It can do the summarization or generation very, very efficiently. Then that there I can go for large language models because there it is already doing a very good job. I don't need to do anything very specific. But when it comes to very, very specific domain, for example, I said for a banking industry, they have to have as a model that can convert their large business swagger files, very specific to banking domain,
mhm,
to certain in a modernized. They are modernizing. They have this large swagger files or their COBOL systems or very legacy systems. They have to convert it into transform into Java or any other latest this one.
yeah.
Then they have to fine tune. The large model may give 50% accuracy, but for their end goal, that may not be enough. That's where
Right.
I can go with a smaller model
Mhm,
where I can fine tune it very efficiently,
mhm,
make it work on par or even better than these large models, and
yeah.
I can just customize it to that.
Mhm,
Right? Say, suppose I have four or five things needs to be done very specific to domain for banking. One,
yeah.
I have to convert the Swagger files. Second, I need to convert their large COBOL system into, say, a Java.
Mm,
Third, maybe another one. So four or five. I can
yeah.
have one model which are trained on these four things,
Mm,
on smaller models which can be trained or fine-tuned on these four things, and it will do an efficient task over there, rather
mm,
than bringing an elephant which
mm,
does multiple other things which may not be
right.
required there. So
Yeah.
that's
Yeah.
how we have to actually split this based on, first of all, understand what is the use case. That is the
Mhm,
first task, whether it's a summary, whether what type of use cases are. Then we go for whether it's a common use cases, other like summarization common task, or is it domain specific task.
yeah.
Even within that domain specific task, how many tasks I can combine so that
Mm,
one model can do these multitasking, maybe three, four. So I think that is how we have to go stepwise, hierarchically, and then decide on that.
okay. That was very well said. Thank you for explaining that. I know we are over time. Do you still have about 10, 15 minutes? Or
Yes, certainly. Yeah,
okay,
should be.
great. Because it's a very interesting topic. So thank you.
Yeah.
So the other thing I was curious about, based on what you said earlier in the presentation, you said that you had used 500, I guess, records for as fine tuning. I think that's a number you said, right?
Yeah,
Okay.
appropriate.
Approximately. Okay. So again, with my limited knowledge of the fine tuning, that just sounds like a small number. So my the question is that all it takes for is that a very unique case of star coder, or broadly speaking, fine tuning, is that the order of data we use to fine tune, and how long does it usually take?
Yeah. So see, 500 is just a representative number.
Yeah.
It see very we also tried with 100 or less than that where we did not see much change over there. So
Yeah.
500 I feel is a for a smaller model for a SLM I think it's a number to start with. That's what I
Mm,
feel. The more you
mm.
add I think that should be good, but anything less than 100 or 200 may not be enough actually, even for
Okay.
a SLM to do that. So even for traditional AI ML, we used to go with at least to have a few hundreds of data points for us to fine tune our CNN or any other neural network as well as, or even the machine learning model. So I think that's a very representative number, but I feel at least we should have those many data points to if you want to fine tune. That's what my
Okay.
suggestion would be. The time taken, see, generally, if you have a GPU, even with one
Mm,
GPU can do that. I think
mm,
it takes few hours of time. So it
mm,
should not be, it's not a very long process. Of course, we tried out a very, I would say, crazy thing that we tried out with almost 20,000 odd data points
mm,
for some of these big, larger models as well. We tried out.
mm,
So they took possibly few days of time, so 3 days, 4 days, kind of. It depends.
mm,
It also depends on the number of GPUs you have, infrastructure you have. So
mm,
it's dependent on the infrastructure and also the amount of data you have. But
mm,
I think if you have 500 kind of like few hundreds of data, I think it
mm.
should not take more than few hours of time.
That's pretty.
That's the time period, the duration that I look at.
Okay, okay, that's pretty amazing. And you were comparing in the presentation, I believe, Code Llama and Star Coder, and you said that after fine tuning both, Star Coder just did so much better. So the question I had was, you found out that Star Coder is better after going through the fine tuning process. Are we at a stage? Do we know why is it better? Do we have enough information about the internal architecture of these things so we know in advance, or is it a matter of just you have to experiment to figure it out?
It is very much dependent on the data. Again, I
Hmm,
want to
I
call it
see.
out. Certain
Okay.
data, possibly,
Hmm,
see, we have also seen certain SAP data we try to fine tune. We
hmm,
had a very bad experience of the catastrophic forgetfulness. That is one
hmm.
very major, like people are experiencing it, and we saw it in first hand.
Yeah.
How, as we added more and more data,
Hmm,
even we went ahead with we chunked the data, did it in iterations as well. Even then,
hmm.
we could see that. So it again depends on the data. So the
Yeah.
data dependency is very much here.
Yeah.
So sometimes if your new data is not aligning with the
Hmm,
kind of data it has been trained on, or
hmm.
if there is a gap there, still there is no specific or well defined how do we make out that data is aligned or not. Those are not at all well defined now. It's purely
Right.
experimentation. If
Right.
your data is not aligned, then we see this catastrophic forgetfulness where it
Hmm,
whatever it has been doing already also goes down.
hmm.
So that we could see. So it is very data dependent,
Yeah.
and that I really want to call it out. So that's why like it's possibly over a period of time we would have more insights coming up with all these
Yeah.
experiments, people trying out possibly the why this drift comes in, like we may get an idea. But at this point of time it's more of from the different experiments we are doing, that we are trying to identify. So but one thing that I feel why this is why SLM behaves well when you fine tune is probably because of the amount of data that it has been trained. It's like the very simple analogy I give is, adding a glass of water in a smaller vessel rather than adding a glass of water in an ocean. It's
Hmm.
like, trillion parameters, you add a few data points doesn't create much. So that at a high level possibly that may be the like explanation, but that's not the actual case. Again, like it is very dependent on the data that we are adding. So I think that I wanted to call it.
Okay. Thank you. That's helpful. And just the final area of questions I wanted to focus on is your area of work on code generation capabilities of LLMs. To begin with, a couple of times you mentioned that GPT-4 is very good at SAP data, which you discovered. I just want to understand slightly better. What do you mean by that? I mean, SAP is a software largely screen-driven. There is some custom way to code SAP. You mean GPT-4 has been trained in publicly available tutorials on how to use SAP? Is that what you're referring to, or?
Right. So
Mhm.
when we compared, see, possibly we do not know what data they have used for training these models, but
Right.
when we benchmarked, what
Mhm.
we have seen is GPT-4 is slightly better, at
Mhm.
least 10%, 20% possibly compared to all other models, be it
Mhm.
Llama models, Mistral, and we have tested almost 5 to 8 different models that we. So possibly GPT-4 would have been trained on more SAP data compared to the other models. So I think that is what I view it. Still, we do not know what is the source of the data that they would have used.
Mhm.
But looks like it is performing better, at least 10-20%. It's better than the other models we have seen.
Okay, understood. And then on code generation capabilities, Dr. Saigeetha, see, there are multiple in the industry, there are multiple kinds of code generation, right? There is full stack application development. There is probably data analytics, business analytics. There is probably on-prem to cloud migration kind of code generation. Then there is maybe things like SAP implementation, Salesforce implementation. Is there a specific class of problems you've
Yeah,
noticed that this work really well?
right. See, code primarily related to code is one area where there is so much promise with generative AI models, the foundation.
Nice. Mhm.
Because we were never successful with all this, like beat code, with whatever use cases related to code, not much with traditional AI/ML because of the variations. But what we have seen, there are four areas where at least I see a lot of potential.
Mhm.
One is code generation. Suppose I give the requirements, can I in a SDLC lifecycle, code generation is one area in the
Yeah.
software development. Once you design, put in a design, you have the technical aspects, then you ingest that to generate the code. So
Mhm.
code generation is one. The second, another area where I see a lot of traction, particularly enterprises are really looking for, is the code modernization, particularly when they have the legacy systems, right? You have
Mhm.
COBOL, you have PL1 kind of legacy systems.
Yeah.
Can converting them into Java or their new version or new code, any language, is a major task, and
Right.
they have to complete this possibly in 2-3 years. Several million lines of code they would have. So I think the enterprises are now looking this as a potential use case across industries. It's not just one industry. I'm seeing it in banking. I'm seeing it in automotive sector. So many industries are really looking at the generative AI for code modernization piece. The third
Okay.
area, again, where people, I'm seeing several organizations looking for, is the code documentation, because what they have is they have one of the client I was speaking with, I know from an automotive sector, they said they have 10 million lines of code just from one geography, some older system.
Mhm.
Even before modernizing them, they do not have any documentation regarding those codes. They do not know what those codes do, whether they are useful, they are redundant, which pieces of codes they have to use. None of no document, because they have been written possibly 20 years back, and those people who would have written would have got retired, and
Right.
nobody to question or to check. So at that one area, another area, third area which I was talking about, where generative AI will play a major role, is the code documentation, to provide the pseudocodes to, even we were like very recently we developed an accelerator that can even generate the flow diagrams from the code, read the
Yes.
code and generate the flow diagram, so that the people can validate it, even verify, validate. You can you can use it as for your documentation. You can check if it is redundant or not. So it is a, actually the advantages is so high, so huge there. So that is the third. The fourth one is defining the business rules, usability of that, optimization, code optimization, by the bug fixing kind of areas, and change management. If there is a change that is made in one a part of the system, can it be replicated in multiple other systems wherever it is all coupled? So I think these are the four major areas I'm seeing a lot of traction coming in from a code perspective. And I feel this is going to go, and we like, initial experimentations have shown that this is possible. There is some success, at least if not full, but the productivity that is coming out of Gen AI, the improvement in productivity is very quite high, and initial experiments have shown that. So I think this is one area where you will see a lot of work being done, and possibly enterprises would invest a lot in this four different areas of code that have been done.
It's very well said. Thank you so much. But thank you. I mean, this is very, very helpful. Really appreciate you taking time to do this. Um, Thanks again.
Thank you. Thanks for this
Yeah,
opportunity
not at
to
all.
Project Pro,
Yeah,
and hopefully we interact and collaborate. Thank
yeah.
you.
We look forward to staying in touch with you.